Okay, so when we were working with these normal distribution curves, we were working specifically with finding the probability that things were less than or between two exact standard deviations, like one standard deviation or two standard deviations above. But what happens is sometimes something isn't exactly one standard deviation above. Sometimes if you have, say, a bell curve like this, and you break it up into its standard deviations, right? I'm going to try to do it very crudely right here. I'm sorry, that's a really bad bell curve. But sometimes you want to find the probability that, say, maybe that you're less than 1.2 standard deviations above. Or what's the probability you 1.2 standard deviations above? And so it's not as easy to use this bell curve to answer those questions. So what mathematicians came up with is they came up with something called a z-score. Okay, the z-score here will help you figure out the probability given that you don't land right on exactly one standard deviation. And here's how you calculate the measure of the z-score. It tells you how far the data is from the mean, in terms of standard deviation. And to calculate it, what you need is first, we're solving for the z right here. Okay. My board's not working. I don't know why it's not working. I can't touch anything. I can't move things around. Everything's not working. Just not. Let's go. Watch, it's gonna pop up on the screen like in 2 seconds. It'll be all this scribbling all over the place. I'm just going crazy now. Yep, there it all. Look at it. Okay, so let me move that up there. So we're going to first off define the z-score right here. That's what the z stands for. You first need a piece of data. Say my height. Let's say my height, what is it? I'm 72 inches. At least I was when I was your guys' age. Maybe I'm getting shorter now because I'm getting old. So let's say my height is 72 inches. And the height of all other math teachers is normally distributed. So that's good. I don't know if it really is, but let's just say it is. So we take a piece of data value, which is my 72 inches. You subtract the mean from the normally distributed set of data. Okay. So let's say the average height for teachers or math teachers is, how about we do 67? Okay. That's the average height for math teachers. And then we have to divide that by the standard deviation for all the math teachers' heights. I don't know, let's say it's just 2. Let's say the standard deviation of math teachers' heights is about 2 inches each way. So if you put these values in here and we calculate that, we do 72. We're going to subtract the 67, which is the average, get that value, divide that value by 2, and it looks like, bam, I am right here. Mr. Benson is 2.5 standard deviations above the average. I'm a tall math teacher is what that's saying. A tall math teacher. That would put me like, wait, here's 1, there's 2. That would put me up right here, like 2.5. So I guess math teachers are really short, looking at the data that I just made up. So anyway, that's how we use z-score. And the following problem, I'm going to show you how we can use z-score to answer an airline problem on travel. Okay.